Minglava. In these videos, we are going to talk about classification. In the previous videos, we have talked about the regression, which is commonly found under the supervised learning methods. Right now, classification. The goal of classification is to classify a new data into a predefined category using the prior knowledge learned from the training data. So this is also one of the supervised learning problems. Right. Some of the known classification problems are like detecting the gas patients, whether the customer is it or not, right? Checking the email if it's a spam or not, or in the financial analysis like fraud detection. Right? So these are the common classification problems. So these classification problems can be further divided, all right, into binary classification and multi-class classification. Binary classification refers to labeling and assigning data into one of two classes. So you only have two possible outputs, right? For example, either yes or no. Okay. In the multi-class classification, it classified the assigning data into one of more than two classes. Right? It can contain more than like 4 or 5 classes here. We also could have another problem, multi-level classification, that predicting new data into one or more classes, more than one class, right? But this is out of the scope of this video. Okay, now let's test our understanding on binary or multi-class problem, right? Let's check, okay, the email, whether it is a spam email or not, all right? So classifying this email into spam or not, or checking if the customer start using your product or not. These are considered binary classification. But imagine you are given a handwritten numbers, right? So you are given a handwritten numbers and you are supposed to classify it into one of the digits 0 to 9. This is a multi-class classification problem because you have more than 2 possible outcomes. In this particular example, you have 10 possible outcomes. Similarly, given a new data, right, classifying this new data into one of the species is multi-class problem. So we need to understand whether we are trying to solve the binary classification problem or multi-class classification problems. Right. Now, let's start to study machine learning methods for classification problems, either binary or multi-class. Okay, some of the most popular classification methods include like logistic regression, KNN, support meta machine, naive-based, decision tree, and random forest. We will start with logistic regression. So, similar to linear regression, logistic regression models the relationship between a dependent variable, your target y, and other feature x using a linear equation. Right? So this is the same with linear regression problem. Okay, you have this linear equation. But in logistic regression, what we do is we use a symbolic function to estimate the probability of the event occurring by feeding the result y into this symbolic function. All right. So let's look at how the symbol work. So if you plot the symbol function, this is a graph that you will get. Okay. So if y is less than 0, all right, if y is less than 0, if you look at the equation, if y is less than 0, it will be exponential minus infinity will become exponential infinity, right? So exponential infinity will become very large, and then 1 by 1 plus infinity values will approach to 0. So if y is less than 0, your h of y will approach to 0. All right, your h of y will approach to 0. If your y is 0, exponential 0 will be 1, and then you will get 0.5. Right? H of y will be 0.5. Likewise, if your y is more than zeros, greater than zeros, exponential minus infinity will approach to 0. All right. So you will get 1 for your h of y. So with this, what we can do is that new data belongs to the class 1 if h of y is more than 0.5 and class 0s otherwise. Okay. So this is how the logistic regression works, right? So if we summarize it, logistic regression is first combine your independent variables using a weighted summation. All right. So first of all, we start with the multiple linear equation, which is a weighted summation of your inputs. Then outcome from this weighted summation input y is fed to into the same y fashion to estimate the probability of answering data belonging to the class 1 or class 0. Right. So these logistic regressions are the parameters for these logistic regressions are usually estimated using the maximum likelihood estimation. Right. So now let's see how we can do logistic regression in Python using the sklearn. Right. In this example, we will use the cancer dataset downloaded from the Kaggle. We first impose the data using pandas. Right. So if you see the info of the data frame, there are 569 records with 31 attributes. Okay. And the data is already clean. Right. The data is already clean. And our target is a class. Okay, whether this patient has been treated as a cancer patient or not. All right. So we have this call and call class. We will use this as a target. So we are left with 30 independent variables, 30 features. Okay. Right. So this is how we define the y and x values. Then we will impose the train test split from the model selection to split the data into training and testing. Here we use 30% as a testing size and 70% as a training size, right? So we have the 171 records of the testing site. Then if we look at this 71 records into a further, 108 records are cancer patient and 63 records to non-cancer patients. Right. So the data is really not imbalanced. Okay. Then in the training, we have 398 records. Now let's do the impose the logistic regression from the linear models, right? So we import the logistic regression from linear models, and at the same time, please take note that I also import the standard scalar from preprocessing, because it is important to scale the data before performing the logistic regression here, because it's also based on the linear method, all right? So in this example, we use a standard scalar. You can use other scalar method that we have discussed in the previous videos. Right. So we use a standard scalar method to scale the data and then do the logistic regressions. Right. So then, like our linear regression, you use the fit method to train the data, and then score method to compute the accuracy. Right, to compute the accuracy of classifier. Okay. So in the linear regression, we use the R-score and mean square errors to evaluate the performance of your regression model, right? So in the classification, we use the confusion matrix to evaluate the performance, right? So if you look at the confusion matrix, basically confusion matrix summarize your detection accuracy, right? Your accuracy of the model, right? So confusion matrix is shown in the table here. In this example, we can see that 107 positive cases and 16 negative cases were correctly classified out of the 170 records from the testing data, right? So how can we calculate the accuracy? Accuracy can be calculated by dividing accuracy can be calculated by dividing the correctly classified samples by the total number of records, right? Here, we have correctly classified 107 positive cases and 60 negative cases. So you have the 167 correctly classified, right? And then divided by 171. So the accuracy of this model is 0.977. All right. Okay. We also use other parameters to measure the classifiers. Okay. Another evaluation matrix to measure the accuracy, measure the performance of your classifier is a precision. Right? Precision measure the percentage of true levels. In this particular example, we have 110 positive cases. All right. So we have our model has labeled 110 cases as positives. Okay, if you send me out the first line, all right, first line, we can see that we have labeled 110 as a positive cancer patients. But only this out of 110, only 107 are true patients. So the precision of our model will be 107 divided by 110, which is 0.973. Okay. Likewise, we can compute the recalls. Recalls measure the percentage of accurate patients detected. In this example, we have 108 patients, cancer patients, but only 107 were detected. So our recall will be 107 divided by 108, which is about 0.99. All right. So all this precision, accuracy, and recall can be calculated using the classification report from the sklearn matrix package. All right. So you first have to import the classification report from sklearn matrix package, and then you call this function by feeding the y dash y predict. All right. And you will be able to print out your precision, recall, as well as the accuracy values. All right, that's all about the logistic regression and then how we can measure the performance of the logistic regression using the evaluation matrix. And the implementation of logistic regression classifier is quite easy in using the sklearn libraries. Okay. In the next videos, we are going to talk about k-nearest neighbors and other classifiers. Right. Thank you. See you all in the next video.